Hello everyone, welcome to this video. In this video we shall be looking at another question from differential equation which appeared in IIT-JAM exam 2022, right? So this is a numerical answer type question and it is a 1 mark question. So here in this question you are given that for this particular differential equation, this differential equation is given to us and yx is given to be its solution. Then for this particular differential equation and defined on this interval 0 to infinity, we have the condition first of all that y at 1 is equal to 1 and that the positive limit of x tending to 0 positive of y of x, this exists. So using these two conditions we are to tell what is the value of the derivative of this function y of x evaluated at the point x is equal to 1. So this is the question, right? So let's start and solve this question. So this is a simple question if you know few things. Now notice that, let me rewrite our equation. Our equation is that x square y double dash plus x y dash minus 4y, that is equal to x square. This is the given equation. Now you see, if you look at this equation, this is a Cauchy Euler type equation. This is a Cauchy Euler equation. Now what is this kind of equation? Equation where you have x square multiplied with the double derivative of y, right, plus some p, some constant value, right, p into x into y dash plus q into y, that is equal to some other quantity, say r, right? It could also, this r could also be 0. So here you see the main thing that we require is that with double derivative we should have x square, with single derivative we should have x. So this is a Cauchy Euler kind of equation, right? And for this equation what do? We just substitute, we just change our independent variable. In this case your independent variable is x. So here what we do, we change our independent variable from x to z. We substitute x as equal to e to the power z, right? So that when you make the substitution, you now have another equation which is x square, not x, y, because now we are taking z. So your new equation is y double dash plus p minus 1 times of y dash plus q of y, right? Plus q of y is equal to, say, r, right? So here your independent variable in this case is z, right? And notice that here y dash represent dy by dx and here y dash represents dy by dz, because we are now taking the independent variable as z. So this is how we solve our question. So because this is a Cauchy Euler equation, we substitute x is equal to e to the power z, so that in our case if we compare this given equation with that of this equation, so when we compare equation 1 with equation 2, so we have the value of p as equal to, you see it is equal to 1 and the value of q is equal to minus 4. If that is so, so our converted equation using this transformation or the substitution, we now have the equation y double dash plus 1 minus 1 into y dash plus q times of y. So this is equal to e to the power, it was, here it was r, in our equation it was x square. So because we had x square here, so let me show you, we have x square here, so it would now become e to the power 2z. Why? Because we have made, we have substituted x is equal to e to the power z, right? So this is a reduced equation. Now we can very easily solve this equation. So let me write down y double dash minus 4y, this is equal to e to the power 2z. So this is, say, this is your equation 3. Now this is a very simple equation having constant coefficients, so we can very easily solve this. For that the solution to this equation, the solution would be divided into two parts. So your y of, now not x, y of z, because the independent variable here is z, it would be the complementary solution plus the particular solution, because we have a non-homogeneous kind of equation. The right hand side, that is not exactly equal to 0, right? So here we firstly calculate what is your y of c. So for that we would write your auxiliary equation. Now what is that equation? So you take the left hand side, you have the double derivative, so you could write it as m square minus of 4. Instead of y, you can write 1. For y dash we write m square, for y double dash we write m square, for y dash we write m, and for y we write 1, right, for the auxiliary equation. Okay, so using this thing, we have m square minus 4 is equal to 0, so you have m is equal to plus minus 2, right? So you got two values of m, so therefore your y of c, the complementary solution, it would be some constant, say c1 times e raised to power plus 2z, the independent variable, plus c2 times e to the power this second root, that is minus 2 of z. So this is the complementary solution. Now talking about the particular solution, you see the right hand side, that was e to the power 2z here, right? For this right hand side, we assume that, let us assume, because whenever you have e to the power something, you assume a solution, particular solution of a similar kind. So you say some constant a multiplied with e to the power 2z only, the same function, right? Where what is this a? Your a is obtained when you divide it, when you divide 1 by the left hand side. So you have m square minus 4, where what is your m? That is the coefficient of this function, so it is 2. But you see, when you plug this 2 here, we have a is equal to 1 by 0, so you have infinity here. So this is a case of failure, so we won't take this case. So we have to change our particular integral here. So what do we do? So let us discard this one, yp is equal to a e to the power 2z, and now select. So what do? We just add one z here, the independent variable, to this value, right? Where what is your a? That is again the same value, right? So your a is obtained when you have the derivative of the same value. So the derivative of 2 m square minus 4, what is that? It is 2m plus 0, right? And where what is m? M is again 2, right? So what is your yp here in this case? It is 1 divided by 2, the value of m is 2, plus 0 z e to the power 2z. So you have 1 by 4 z e to the power 2z as the particular solution. So this is your yp. Now you have yp, you have c, the complementary solution, and the particular solution. So what is your answer here? So you have c1 e to the power 2z plus c2 e to the power minus 2z, and your particular solution was 1 by 4 z e to the power 2z. So this is the solution in z, but what do we require in the question? We require the solution in terms of x. So we substitute back whatever we have assumed. So we have used this transformation that x is equal to e to the power z. So either we could use z is equal to log of x, or simply e to the power z could be replaced by x. So we have c1, so e to the power 2z could be written as e to the power z square, right? So it is x square here, plus the second term is c2, it could be written as e to the power z raised to power minus 2, so it could be written as x square x raised to power minus 2, right? And the last term z is equal to ln of x, and e to the power 2 z is what? It is your x square, right? So this is your solution. Now what about these constants c1 and c2? For that, so we say this is our solution, right? This is the solution of equation 1, and this was the solution of equation number 2, right? I guess it is 2. Let us check here. No, it is 3. So this is the solution for equation number 3. Okay, so we have the solution. Now you see here in the given question we have y of 1 is equal to 1, one condition, and this limit exists. We have these two conditions with us. So let's use them one by one. So first condition is y of 1 is equal to 1. So using this condition we have 1 is equal to c1 1 square plus c2 1 raised to power minus 2 plus 1 by 4 times of ln of 1 multiplied with 1 square. So when you solve this you have c1 plus c2, and what is log 1? That is 0. So you have c1 is equal to 1 minus c2. So you obtain one constant in terms of another, right? So you have, this is one thing, and moreover you have another condition that limit x approaches to 0 positive of this exists. So let's see what do we obtain from here. So whenever you apply the limit to the function y of x, in this case what is it? It is c1, let me rewrite my y of x, c1 x square plus c2 x to the power minus 2 plus 1 by 4 times of ln of x into x square. So this was your y of x, right? When you take x approaching to 0, this first term would approach to 0. This term would be because you have x square here, would also approach to 0, and here you have in the denominator x, so that means you would have 1 by 0 term. So that means this term would tend to infinity. So this would make this limit not existing, but in the question it is given that this limit exists. So that means the second term has to be removed from this part. And how can we do that? Whenever we take c2 is equal to 0, right? So this is achieved whenever this exists, whenever c2 is 0, and if you have c2 as 0, your c1, it was 1 minus c2, so you have c1 as 1 minus 0, that is 1 only. So therefore your y of x is equal to c1 times x square. C1 is 1, so you have x square plus c2 is 0, and the third term was 1 by 4 times of ln of x into x square. This is simply your solution. And in the question they are asking what is the value of the derivative evaluated at x is equal to 1. So let's compute its derivative. That's simple, 2x plus 1 by 4. As such, the derivative of log x is 1 by x plus log of x. As such, the derivative of x square is 2 of x. So what is y dash of 1? So you have to substitute x is equal to 1 here. So you have 2 into 1 plus 1 by 4. Here 1x cancels with this one. So you have the value of 1 only, plus 2 into 1 into log of 1. And log of 1 is 0. So you simply have 2 plus 1 by 4 here, right, which is equal to 2.25. So your final answer for this question is 2.25. So I hope you understood this question. Well, that is it for this video. Thank you for watching.